In this video, we will dive into the contains method in LINQ. Imagine you have a collection, like a list or an array, and you want to know, is a specific item inside this collection? That's exactly what contains helps us find out. Contains gives us a straightforward yes or no answer, in technical terms, a Boolean value. It returns true if the specific element we are looking for is in the collection, and false if it's not. This makes contains incredibly useful for quickly checking the presence of an item. Here's how it works. We begin with our collection, which can be any enumerable set. Then, we use the contains method, passing in the item we're looking for. It's that simple. But contains is more than just a basic search tool. It can be enhanced with overloads, such as custom comparers for complex types or case-insensitive searches in strings. This adds a layer of flexibility to our searches, making contains a versatile method for various scenarios. In this video, we will explore contains through practical examples. We will use it with different data types, like arrays, lists, and more complex structures, to see how it can be applied in real-world programming tasks. So, let's get started and see how the contains method can make checking for items in collections both easy and efficient. Imagine we have an array of integers and we want to find out if the number 7 is in it. Here's how we do it. We use the contains method on our array, and inside the parentheses, we put the number 7. In this case, since our array does have the number 7, the result will be true. The good thing here is that we don't need to use any complex queries or lambda expressions. We just directly use the contains method with the value we are looking for. Please make sure, the value must be of the same type of the data we have inside the collection. For example, here we have a collection of integer numbers, therefore the value we want to search for must be of type integer, and so on. Now, let's look at a different example with a list of strings, where each string is the name of a fruit. We want to find out if apple is in our list. When we use the contains method, we see that the result is false. This is because the word apple in our list is in uppercase, but we searched for it in lowercase. But what if the case doesn't matter to us? We can still find apple regardless of how it's written by using a different version of the contains method. This version is the second overload, and it uses a string comparer that ignores case. When we use this query, we get true because it sees both apple and apple as the same. As you can see, we are working with a collection of strings, therefore we used a string comparer. But in case we have another data type, we have to use another comparer. Next, let's consider a dictionary where the keys are integers representing product IDs, and the values are the product names. We want to check if there is a key with the number 90. To do this, we use the contains method on the keys collection of the dictionary with the ID 90. Keys is a property of dictionary type, that returns a collection of the keys we have inside the dictionary. The result is true because the key 90 is in the dictionary. However, there's an even simpler way to check for a key in a dictionary, the contains key method. With this method, we just need to call it on our dictionary and pass the ID we are looking for. The result, as expected, will be true. Let's explore a more advanced example using XML data. Imagine we have an XML file that contains a list of books, each with a title, an author, and a set of genres. Our goal is to find all books that fall under a specific genre, such as LINQ. First, we load the XML file into an X document. Here's the query to achieve the task. First, we go through each book in our XML. For each book, we grab the list of genres and then check if LINQ is one of them. This is where the contains method comes in. We apply contains to the collection of genres for each book, to see if it includes our specified genre. But, instead of just getting a true or false answer, our query is designed to select and return the titles of the books that match our criteria. We achieve this by using the select statement to extract the book titles where the condition is true. The result of our query is a list of strings, each representing the title of a book that's categorized under LINQ. This approach not only checks for the presence of a genre, but also retrieves valuable information based on our condition. In summary, this query demonstrates a sophisticated use of the contains method in the context of XML data. We are not just finding out if a genre exists, we are filtering and extracting specific information, the titles of books in this case, based on that genre. This showcases the power and flexibility of LINQ in processing and querying complex data structures like XML. To wrap up, the contains method is a simple yet powerful tool in LINQ, offering straightforward functionality for checking the existence of an item in a collection. Whether you are dealing with basic types like strings and integers, or more complex structures like XML and dictionaries, Contains provides a versatile approach to data querying. Its ability to integrate with custom comparers adds flexibility, allowing it to handle diverse scenarios with ease. Remember, the efficiency of Contains can vary depending on the type of collection, so it's important to choose the right data structure for your specific needs. As we have seen through various examples, Contains isn't just about finding if an item exists. It's also about leveraging this capability to filter and extract meaningful information from our data. That's all about Contains method.